First off, thank you all for joining and attending this short 3G and 4G webinar. For those who don't know me, my name is Rico Samarna, the VP of Sales here at IWL. And also for my team, we got Jim Loggen, the KMAX engineer. And in today's short webinar, we're going to show you how to emulate the imperfections of 3G and 4G networks. Those imperfections can cause mobile devices and applications to slow down or even stop working. Users expect your app or device to run well over 3G and 4G mobile networks, but literally, field testing them under all expected network conditions would be extremely time-consuming and expensive. Field testing trips around town and out in the countryside could be fun, but are real killers on schedules and budgets. This is where our KMAX network emulator steps in. With KMAX, you can emulate any network conditions such as 3G and 4G networks in the lab and see how your app or devices behave before deployment. Mobile networks have very different characteristics from wired networks, so your apps and devices will perform differently. Developers such as yourselves need to test apps and devices for mobile compatibility to make sure that end-user experience will not suffer. Since bandwidth is shared and mobile devices are not stationary, mobile networks are constantly affected by ever-changing conditions such as location, signal strength, time of day, weather, number of users on the network, speed of a device physical movement, the technology supported by a connected cell tower, current service provider. Those conditions can be emulated by using 5 core network characteristics. Ideal throughput, which is measured in bits per second, latency or round trip time, which is measured in seconds, jitter, which is randomly varying latency measured in seconds, random packet loss, which is measured in percentage, and the last one, random bits per corruption, which is measured in percentage as well. So now I'm going to pass the controls over to Jim, who's going to demonstrate how KMAX can easily emulate 3G and 4G networks by applying those network characteristics. So bear with me while I pass the controls over to Jim. So Jim, you should have the controls now.
Okay, just trying to share my screen here. Can you hear me?
Yes, I can hear you.
All right, let's see here. Okay, I believe I am sharing or trying to. So let me kind of.
There you go. I see it on my screen. So you're good to go.
All right. Okay, thank you. So hello, everyone. My name is Jim Loggen, and just to reiterate, the 5 network characteristics that Rico just mentioned can be found by measuring them on real networks, similar to ones your users will use. The measurement should be done by neutral parties, not carriers, to avoid selection bias. Lots of measurements, of course, should be taken to improve the statistics as much as possible. So what we did is we reviewed the existing research literature for you and found a series of studies that contain consistently applied and the usable measurements from which we could derive the network characteristics that were mentioned. We then crunched the numbers, created scenarios that contain those characteristics. The scenarios can be loaded from the KMAX dashboard, which is the GUI screen you are currently looking at. So I'm going to kind of go through this dashboard and eventually go to the scenario. So real quickly, the dashboard is our kind of home page in which we land. And when you log in, there's a quick prompt that says, you know, you agree to our license and you're in. So it's just the KMAX itself is driven by it's a web browser access to actually do it, and you can do it, control it from something as small probably as an iPhone. I think we tried that, but you know, an iPad or any other standard device just to control it. And so the other thing you control it with is, of course, what we have is an application programming interface and so on, so that obviously if you're non-GUI and you want to automate things, you can do that. We won't discuss any of that today, maybe in a future webinar. But for now, we're talking 3G and 4G and concentrating on what it takes and what you need to do to actually emulate 3G and 4G. So when I'm in here, I'm going to go quickly into clicking on that center icon or graph, it actually shows me details of things like drop, duplication rate. What we call these are flows, and it goes into categories and things like that. We can categorize the packets, send them through different flows depending upon perhaps what IP address subnet they're going to, or what type of protocol they are, or just about anything you can imagine that's the contents of your packet. And then we can apply these characteristics, network characteristics. The question is, what do we plug in? So, for example, the drop, what's the drop probability? What duplication is observed on 3G, 4G? What's the rate limit, delay, and bit corruption, and so on. So, and then we can do those in both directions. So these little arrows kind of indicate what's happening there. So what we'll go is scroll back, we'll go back to the dashboard up here, and what we want to do is replace the scenario, and we'll go from our standard library. It says, are you sure you want to replace it? And what we've got then is we've categorized the scenarios that we include with the machine by pretty much network technology or application area. So we have a series of blank templates for you to fill out. A lot of people are interested only in doing one flow at a time. So we have one node, single node, for example. It just looks like this. Basically, something comes in and goes out. So we have that, or we have 2 bands, or up to 32 bands. Unusual situations where you may need to do that. And the machine I'm actually demoing on actually has 4 interfaces, so I actually can do for anyone to anyone, but we won't discuss that. But again, going back to the 3G, 4G, we have cloud. There's some 3G, 4G on the cloud, which is more a case of application. By application, degraded networks, there's a few of these that may be IoT. We have some internal testing, but again, LTE would be also mobile. We have a few of the there and others that aren't relevant necessarily. Voice over IP may or may not be relevant over 3G. Amazingly, there are people actually who use that. So you're actually going over as traditionally a voice network, putting IP packets on top, data packets, and then putting voice on top of the data packets, and that's actually done. But we won't talk about why that's done. So what we've done, so we went through those studies that I mentioned earlier and found that they had done 56 some. Let me kind of select this so you know what I'm talking about. So I'll select one of these. We're just highlighting it to see what it is, and this one's called Mobile 3G Best Case. And with a quick summary of some of those characteristics, like drop percentage, duplication percentage, rate. This is the ideal rate, bit rate, delay, the latency, one way, 123 milliseconds, for example. And then jitter, which is random oscillations around that 123 milliseconds, like 53 milliseconds. And then a quick dashboard diagram, this non-functional diagrams just to be helpful, like mobile app on one side, the cloud. That's useful for directional, like the uplink rate might be 3 megabits per second, the downlink might be 6 or something like that. On these, we basically said 3. We used uplink in both directions. When you need to do it, you can actually just modify our presets and increase that if it's appropriate. There was a reason we did that. Basically, it allows you to basically do kind of worst case, even best case, basically say, you're testing. The whole point of testing is not ideal case. It's really what's typical and what could be typical worst case that covers enough of your potential target customers to know that you've done your best to mitigate those problems that might occur. So we talk about basically the references we've chosen, and so we didn't pull these numbers out of the air, and thus we went through these measurements, and there is some researchers in common with these, but they just happen to be useful to us circa 2012 when these were done. And then we didn't have everything we needed out of these, so and then we looking, and we found some information out of sequence. But this also gave us things like duplication, which wasn't quite measured in some of these others. So, and that was actually done in 2003, but some of the duplication occurs in the core and not necessarily on the edge. And so, and it turns out that these numbers are still pretty relevant. So even though it's like getting a little old there, that those probabilities are still somewhat, they're very low probabilities, but nevertheless they're useful. So basically that's what we've done. And these reports from these studies gave us packet loss, round trip times, and a few other things. But from that, we were able to compute the minimum, mean, median, and maximum values for drop, delay, and jitter. And the duplication came from that this last study here. So the other thing we did once we did that is, you may or may not know what your primary interest is in which technology, mobile technology. So we segregate them by 3G, 4G, and then a composite. The 3G typically was 3 megabits per second, 4G 50 megabits per second. And this is ideal rates. And then 26 was kind of what we found to be a good composite rate to say. You don't know ahead of time, but this will give you. But usually there's two of these technologies or two of these scenarios that we've created that kind of bracket. And that would be the 3G worst case here, which I'll highlight. And then the other one is 4G best case, which is kind of the best you're going to likely see. So if you can't do support reasonably well the 4G best case, you may have some issues. you will have to look into 3G worst case. If you can't do that, then you may or may not say, let's try that. But the other thing is you probably should maybe look to see how well you do on 3G median and 4G median to make sure that that's the case where, let me get this technically correct. They represent the worst level of some impairments that half of the users would have seen at those dates those measurements were made, meaning the impairments at median basically are like that. So let's kind of bring this up and load this in, since I'm using up a lot of the time here. We'll go 3G worse. And what it does is it brings up this little reminder diagram. We go into here. And then over here, we now see there's values. If I just hover the mouse over, we got 0.66% probability, 0.05% probability up to rate limit of 375. Or if I click on this, 3M for 3 megabits, and I say, oh no, I want 6 megabits, I can type that in and change it. And it'll go up like that. And there's various hooks and things. We have advanced options for more sophisticated stuff we won't go into that makes life interesting in terms of what you can do if you're interested in core, like random early detection, token bucket, various things that control that bit rate. So we go like that. The little highlights here, impairment node key tells us we're non-default settings. If I go and do like this, basically now I'm bypassing all of those. I clicked on this. So I can actually shut off the impairments in one direction or both. Or if I go into, for example, drop, it says 0.66, and of course I can modify that to 1.66. We have various burst capabilities. Just by clicking on this, I've turned off the drop temporarily, and that's really handy if you just want to isolate one particular impairment at a time. Alter we're not using is bitrate. Bitrate is pretty much difficult to measure, so a lot of people simply don't have that unless they go to the lowest levels. And so instead of that, fortunately, we can go to packet drop to get an idea of what the target stuff is of that. It's not the greatest, but that's what we have for that in terms of that. And then the other thing we did is the filtering. Now, it turns out something like ARP is rarely, not always, it may or may not go through the over the wire. ARP is just sort of IP to Ethernet, and obviously Ethernet is not necessarily relevant to mobile applications. It's not Ethernet over mobile, it's IP. So ARP, we want to do is bypass any of the impairments. It's just link layer between point to point. And so we have a section that says if the ether type, so this is where we can see that we can actually match on, for example, in this case, we're doing ether type. And there's a lot of different fields and things I can't go into. There's not time. We do have DNS, DHCP, which optionally, we aren't using it, but we've set it aside for you really quickly. So if the port number is 53, 67, 68, either source or destination, and it's UDP, then send it through this DNS, DHCP path. And the reason for that is DNS and DHCP services are usually much closer physically and hopwise, router hopwise, to the two endpoints. So you would do that probably to speed those up and give those slightly different characteristics. Here's the ARP bypass, and we've got nothing turned on there. And then this is the optional DNS DHC path, at which point we might maybe put in higher delay and put in like, oh, you know, I mean, not higher, but a different delay than 0. So it's like, okay, delay now here's 6 milliseconds, whereas, you know, if it's going through the farthest point, it's much higher. So, but it's still disabled here unless I go and say, oh, enable that. So go enable that. And now here you can see it's now active, and here it's still disabled the other direction. Just kind of showing you some of the modifications you can make. Once you've made those modifications, you can export it to your local machine, save it, and then reload it later. And I can say this is 3G case _1, for example, and I save that. And there's that going. So what I'll do here is I've had some ping going stuff on the background. Let me kind of bring up a little bit of a, give it a couple minutes. Okay. So I'm now running traffic, attempting to anyway. So basically what you see here, let's kind of bring that up. What it's doing is because you can see this little color diagram shows the traffic. And here, this iPerf down here is really trying to get the stuff through. And we can see that we're doing kbits per second. So let me kind of bring up a little chart here really quickly. Go bits per second here. Bits per second. So we can kind of see what's happening in both directions. And I'll bring up the speed to about, let's go max speed here. And so we can actually see how it struggles and stuff. But if I go like this, and if I simply do bypass here and bypass here really quickly, go back to that chart. Well, actually, when I go that, let me put that back here, and let's just go and manually disable some of the stuff quicker. Disable. So, and then now we're going to see some little bit of about, you know, 6 megabits per second, which is about what it's oscillating around, and it has some problems kind of getting through, but the other thing we've got going on still here is that and that. And the other thing we can do, by the way, on any of these things is we have this waveform expression to allow you to change things with time. For example, a probability, the dupe probability, I can apply that and then run that. And what happens is that the dupe probability goes up in time, for example, hangs there and then comes down. I can give it as equations. I can give it lead time pulse model or a series of line segments to do this sort of stuff. But that's how we can actually modify things in time. And if you have, you're going to have multiples running those on different parameters, and they would be synchronized with each other. So you can actually do things that way. We'll go back to actually what I should do here. Go back to manual override and apply. Okay. close that up. So let's see here if I've gone through everything I'm interested in showing you today for this. Obviously, I didn't go over a number of things that we could have, one of which is if you do have a mobile device, our device uses Ethernet. Question people often ask. Great, how do I test it? Obviously, you've got this. We presume your device software is IP based, and from there, it doesn't matter if you can run it on test device that has happened to Ethernet or happen to have Wi-Fi. You can set an access point in front. There are a couple other possibilities, but like I said, we don't want to spend too much time on that simply because we don't have the time, unfortunately. So the biggest thing I want to make sure you understand is that we do have basically a lot of preset scenarios that make your life easy. You can just load and go. Basically, you go in and select them from our standard library and choose what you think is appropriate, modify them if you wish, and save them and reload them. And so you can explore conditions. And I should point out, we also verified that the numbers we are using here, that we could consistently replicate what the those researchers actually observed in terms of TCP throughput. So because they put in something like much larger, they would say, oh, it's 3 megabits per second ideal, but they saw much lower than that. And once drop was shoved in there, drop is actually kind of the hardest hit thing to hardest hit TCP. So I think that's it from my point of view. I think completion of the KMAX aspects, and I'll turn it back over to Rico.
So can you put up the, yeah. So Jim just showed you how to emulate 3G and 4G networks with our KMAX network emulator. So with this capability, you can test your app or device in your lab before deployment. Thank you for your time. And if you guys have any additional questions about KMAX or even just 3G and 4G network, feel free to contact me at sales@iwl.com or just visit our website, iwl.com. Thanks again for your time.